Good evening, sir. I am B. Saichan and I am from IT department B section, and my roll number is 21951A1269. And today's topic is storage system supporting for continuous media applications, and second one is multiple disks, memory and integration. So why study multimedia? Why study multimedia? Outgrowth from industry, telecommunication and consumer electronics, television, improvements, telecommunication, environments, communication and for fun. So continuous media, subset of multimedia including timing relationship between server and client, stream, like video, MP, H261, AVI, like audio MP3. So multimedia resources requirement. Step up in media requirements, more bytes, but not as much as some applications, graphs or transaction processing. Influences on quality. This is server, this is client. So this is the diagram, data loss and all. An end-to-end problem. Server applications, operating systems, networking protocols, network routers, and client applications, operating systems, and network protocols. So these are the left side ones are client servers, and this side are clients. So transition OS support, same arbitrates resource demands, efficient abstraction of low level devices, convenient, different, no longer just protect memory of process, negotiated slice of CPU time, IO bandwidth, timings. So OS problems is in supporting multimedia, process scheduling, memory management, storage scheduling and network interface. So this is a delivery system from the server to the systems network. So from application, from the client file are taken from that applications and communication systems. Several disks to manage memory transfer, several in memory data movements and context switches. So memory caching, application file system, disk communication system and network card. So caching possible between application and file system, and file system is cache. It has some drawbacks. From that it goes to disk. Garbage. Efficient secondary storage usage must take into account that use of secondary storage there are large access time gaps, that is a disk access with probably dominate the total execution time. There may be huge performance improvements if we reduce the number of disks access. A slow algorithm with few disks accesses will probably outperform a fast algorithm with many disk accesses. So several ways to optimize: block size 4 KB, file management, data placement, various disk scheduling, scan rewrite, derivate, and multiple disks. A specific RAID level, prefetching means read ahead prefetching, memory caching, replacement algorithms. So need for application specific algorithms. Most exciting systems use a LRU variant. So keep a sorted list, replace first in list, insert new data elements at the end. If a data element is re-accessed, example new client or rewind, move back to the end of the list. So extreme example, video frame playout. Play video 7 frames. 2 3 like this, everything is inserted, and here it goes. Note 4. Parallel access. Disk controllers and buses manage several devices. One can improve system performance by replacing one large disk with many small accessed in parallel. So several independent heads can read simultaneously. So disk controllers, a bus manage several devices. One can improve total system performance by replacing one large disk with many small accessed in parallel. Several independent heads can read simultaneously. Another reason to use multiple disks is when one disk cannot deliver requested data rate. In such a scenario, one might use several disks for stripping. Bandwidth disk B disk required bandwidth B consume B disk B consume. Here the client first takes advantages of the stripping are high data rates, higher transfer rate compared to one disk. Drawbacks are can't serve multiple clients in parallel, positioning time increased. So mirroring. Multiple disks might be come in situation where all requests are one for disks and rest lie ideal. In such cases, it might make sense to have replaces of data on several disks. If we have identical disks, it is called mirroring. Advantages: fast response time, survive crashes, fault tolerance, load balancing by dividing the requests for the data on the same disk equally among the mirror disks. So drawbacks: increased storage requirements, more expensive write operation. So that's all in this presentation. Thank you.